please give a round of applause for our next speaker, Prasan, who is the head of product security at AppUX.
Thank you.
Just a small reminder, please, if you have any questions, go at BSidesSF.org/Q&A and you can leave your questions there during the sessions. And if we have time at the end, we can cover them at the end of the session. Thank you.
Thank you. Hello, myself Prashant. I work as a product security head for AppUX. AppUX is into certificate lifecycle management, PKI, PKS service, and SSH, so related discovery, predominantly into the mission identity space. And so today, like we're going to look about the ironclad PKI, basically like why PKI needs all the attention that it requires now, why it matters now, what are all the pitfalls that we currently have, and what is the timelines and urgency that we see towards it. Okay, so I put it into 3 buckets just for a better understanding and a flow. Weakness in today's PKI, post-quantum impact, and building crypto agility. So the first one, the weakness in PKI, today's PKI, we will look into, like the practices in PKI, like what's going wrong and what are all the gaps that we have and what kind of problems that we see, like from a real world perspective. For example, like, how does this affect me as a user and how the company should look at this and what are all the areas that we may not be, paying attention to today, like where it has been legacy and what's getting changed, those ones. And the post-quantum impact. So far it's been a theory, like post-quantum, like, it's moving from a theory to more kind of, reality right now. And do we have timelines towards it? What are the problems that we face if post-quantum computing comes as a reality? And building the crypto agility. So what is crypto agility and how are the organizations like crypto agile today? And looking at the real world data, what do we see? What are the current timelines for a certificate rotation, and what does it take like for companies to implement crypto agility? How do we better prepare ourselves both in the light of quantum computing and also given the latest mandates that are coming up from NIST and CA Browser Forum, similar ones? Why this matters now. So 72% of organizations experienced at least one certificate-related outage in the past year, and in like 67% reporting monthly outages and 45% weekly. So now this could be both, public and also like private certificates. Now, what are the things that we know at the wake? Like, what do we know, which we have seen, which has impacted us? We'll get into it. But as leaders, and practitioners here, you would have seen, like, you may have like understood, like, what is the impact of like a certificate getting expired where I don't have a monitoring available for it, or, an automated process for us to like rotate it. Now, real world incidents on the rise, we discussed about it, and shorter validity of TLS certificates. So it's not anymore optional that we need to have like monitoring for certificates. We need to have the rotational policies. We need to have automation enabled. This has been like, depending on the size and the impact of certificates for a company and organization, this has been taken into consideration so far. But going forward, this seems to change. The reality seems to change because a lot of changes are coming in this area. And from now, because let's say, the time that I have put this content, I had to continuously change it more than twice because so much updates have come in this area. Like even, today I had some changes happening because that much attention, that much changes are happening in the space of like PKI and certificates here. We will look into this. Lack of crypto agility and regulatory mandates. So NIST and NISA, a few other, like UK government and few other bodies have brought towards like what are the proposed algorithms to use, how do we stay secure, what to move towards, all those things. So the incidents over the past year, like we have taken like, last 1 year, but one thing that I did is like I also included the Starlink in there just for its, the amount of importance that it has got, like, how the certificates are used, where it's used, what kind of impact it could have. So interest, so most of the organizations in the globe like have been using interest as a CA, but it has gone through a distrust by Google and there have been problems, right? Like misuse CAs and the policies not being met. So there have been some issues with it. But what are the other ones like which impacted companies, large scale companies, which also created disruption and also outages in their particular area. So Chromecast, a month ago, Google Chromecast faced an outage. It's because of an expired certificates. All the edge devices, the IoT, like what it says is like, more than looking at it from a perspective of one device or like one particular kind of a device, a Chromecast, this is the same plight for the IoT and other similar devices which are in the edge cases. How do we maintain those devices? It's not just about a domain or an authentication certificate we use. It's also about like the edge devices like which are operating in scale, right? And Alaska Airlines reporting IT outage because of the certificate being expired. And similarly, the bank in the UK, like which has reported that their entire operations had to go down. Like in this case, like most of them have brought up their environment like faster. They were able to like rotate the certificates. But in the case of like Google Chromecast, it took like, more than a day or like two for them to like fix those problems. So this is what we call it as like crypto agility. If something goes wrong, how quick can we, like make a switch, be it an algorithm, be it a CA, be it a certificate. So in the cases of this being going wrong, do I have mechanisms where I could quickly bring something up, quickly make those changes, and make the service available again? And these are from CD logs. So what we did is like we collected the Fortune 500 list and also the most visited US government list from the US Analytics. So this we have run across few tests. One is that we looked into the CD logs to see what kind of algorithms are being used today widely by all the companies. And two, we looked at what are the different sectors and how do they rotate their certificates, how long the cert validity is being issued today. So is it like 100, is it 200, is it 300? So the average that we see is like 398 days for a certificate to be live and also get rotated. Now this is the validity that today 2025 we are talking about how the websites are providing, and this data shows a few findings in there. So more than 78% of Fortune 500 certificates would fail a crypto agility readiness check today, because it depends on like few factors when we call this as like they would fail. One of it is quantum vulnerable algorithms, usage of RSA 204.8 and similar, and wildcard overuse and inconsistent rotation timelines. So now, why do these matter? Now, each one of the fact which we discussed about now is having some sort of, a threat or a change in the landscape or a regulatory mandate coming towards it. So we'll look into it deep. 68% of Fortune 500 and US government certificates still use RSA, making them quantum vulnerable. So when quantums becomes a reality, this RSA could be broken. That's like what we have seen from the SHARS algorithm. And 23.5% of wildcard certificates are used by industrial and manufacturing companies. So we just looked at, with the wildcard certificates being used, overused, we looked at which sector is maximum using these wildcard certificates. Sector-wise, out of these, we have collected this data, and that's what we are looking at here. And if the internet were to be audited today, for quantum readiness or crypto agility, for quantum readiness for that matter, more than 70 to 75% of the certificates that are in the internet today are not quantum resistant. Now, this is what we are talking about as a backlog that the companies will have to look into. Now, this is a subset of data of the entire internet, right? This is like based on Fortune 500 and top 100 or like few websites, which the US government websites which people are using. Now, this is a very small subset of data that we are discussing here. If you will have to expand it to the entire internet, what we look at there would be something drastic and dramatic. So now these are all the tech backlog that we are looking at for the next few years for us to like go back and fix. And agility is not optional. So far, until a month ago, we have been discussing about this certificates has to be like rotated frequently, and we should reduce the just like an identity, what we talk about, principle of release privilege, zero trust, no long-standing privileges. If you would apply the same for certificates, it's also an identity, a machine identity. Short-lived certificates are mandatory, and rotating that certificate on a particular period of time is going to be like mandatory. So far it's not, but so few weeks ago, a month ago, CA Browser Forum has voted that 47 days is going to be the validity for all the certificates starting from 2029. And this is what they have voted for. Google proposed 90-day, Apple proposed 47 days, and this is the final, like vote that CA Browser Forum has come to. What does this mean? So today we looked at it, 398 days is the average a certificate that's being, issued the validity. Now that validity cannot be more than 47 days going forward by 2029. And this change is happening from now. So we will have to start reducing the life cycle of certificates starting from 2026 and similar. And to do that, it's not simple because every company uses 1,000 certificates or more than that, depending on the size and the nature of the company or like where they use it for, right? It differs between banking, it differs between automobile, it's different for like a modern SaaS company. Now the certificate's also being used for like many different use cases, right? The internal versus external, like you call it like public CAs and all that. Now these brings in like different set of backlog which the companies are not prepared for, because looking at the data graphs, it doesn't show the crypto agility the companies have attained, and which is where these mandates are also coming, enforcing people to look at their visibility, the posture of how the certificates are today and how they're going to move forward. So the weakness in today PKI: quantum vulnerable algorithms, long-lived certificates and devices, human errors and misconfigurations, limited crypto agility. Now, we have been, discussing quite a bit about crypto agility. What's crypto agility? The ability to identify and discover the certificates that the company uses and for what purpose, along with context, and then prioritize based on the importance, like what is a crown jewel application, what's public facing, what's internet facing, what's being used for authentication, and then having the policies to implement and fix whenever there is a problem, be it an algorithm change or a vendor change, the certificate where I'm getting it from, my public CA. Any kind of change should have the ability, the company should have the ability to do it overnight. In simple terms, we should have the ability to fix something when something goes wrong in crypto, we should be able to fix it overnight rather than doing it under the fire. So quantum vulnerable algorithms. So there are a few algorithms which we will look into deep detail, like a couple of algorithms which we will look into on what makes them quantum vulnerable and how that could be broken. If so, like when that could be broken and what's going to be the threat that it's getting. Long-lived certificates and devices. We looked at 398 days as the usual certificate lifetime that we have seen from the CD logs. This is for the domains and the public available certificates. But think about the devices. The edge devices usually get 10 years or 5 years as their certificate validity. Now, this could be internal, this could be external, but that device is going to, if that's going to basically, talk to certain other services, then these things which are coming as 47 day and other mandates which are coming could affect them as well. Do we have the visibility towards all the certificates that we are using in a company's environment is question one. And two, along with context and posture, do we have that availability? Yes, the machine identity is a space where the lot of gap is on the context and the posture of it. And human errors and misconfigurations. So the misconfigurations and human errors, the CA templates, or be it the CSR values, the misissued certificates, and this is from one side of things, which can entirely go wrong internally or from a process gap. There are other set of things which majorly not being discussed. One is that the deprecated CAs and then untrusted CAs providing the certificates. So that is equally important, as most of the phishing and other impersonation domains get these certificates from the blacklisted CAs, and that's some kind of monitoring which the companies are not having today. We are working on collecting the logs for that as well. I will publish it as a research. So once we have that available, as we are crunching through a lot of data and identifying the blacklisted CAs. Limited crypto agility, we discussed about what it is, what's the gap, and we all know where we stand. If we will have to look at our work lives and see if this is something normal to do, because there are still companies who track their certificate expiry via Excel sheet and few other automations. Now, how good that help? It depends, because there is a rush, there is a timeline towards it. We will have to basically work against the clock right now. And Quantum 101. So far, like we discussed, quantum was about subject of interest, when it comes to reality, we had no idea. But with the recent developments on quantum computing, so we have seen few differences coming in, and we have looked at the timeline of certain companies like Google's Willow. So Google has published a timeline on when they're going to achieve like what kind of qubits. And this also says like, okay, we are in an era right now where quantum is already there, but it has some noise and it has some errors to it, which over a period of time will get fixed. Let's just take, it's going to be, I'm not saying it's going to be like AI, but when AI was coming, like how many of us did we actually know about it? Like in 2020 or 2021, when, like AI was getting launched, we did have AI like for decades, but the generative AI had a different capability to it. And when it was launched, it was simply a chat application and the use cases differed. So quantum, when it becomes available for like companies to use for the research and other use cases, who would know it could also be used for breaking encryption, which we use today, right? More than 70% of what we have seen is like RSA 2048, which is vulnerable for quantum and over a period of time, not like today's one, but yes, it's happening. So what is the quantum approach of like why this could be broken? I'm just going to simply, keep it very simple here. So the thing is, today, like what we have in RSA 2048 is like, finding it's a discrete log problem is what we have. What would quantum do to it? The quantum is simply going to make it as a period problem, which it is really good at, rather than calling it as a discrete problem, math problem. So this is what Shar's algorithm has shown us. So finding the P is going to happen, finding the, it's going to be the K is going to be a period problem, and this could happen in the polynomial time for us, like when quantum becomes a reality. Now, will quantum become a reality? Yes, we have seen few, cases. We have seen the reality of like where it is today, and we are also like looking at some of the roadmaps to see like when it could become available at what scale. Now to break RSA, like what are we talking about? So we are talking about 4,000 qubits, logical qubits, to be available, and only when that becomes a reality, that's when RSA faces a threat, right? And what are all the real world applications that it could have an impact? Now, the Bitcoin uses the same algorithm, like which is quantum vulnerable, and SSH keys, the TLS HTTPS certificates that we are using today, and the VPNs. Now, is it scary? Yes, but the companies are catching up. The industry is catching up. Apple introduced, like last year, like February, Apple introduced the iMessages. They do encrypt using PQ3, which is like PQZ, compatible algorithm. They use a MLChem as their algorithm for PQC. And similarly, Palo Alto's VPNs and other things are catching up as well. So the vendors are enabling the capacity for the end users and organizations to consume what's already going on as a problem. So it's not a theoretical thing that we are discussing here. It's practical, and the industry is catching up on this. The quantum threat timeline. So the first 25 to like 2030, like what we are in right now is the NISQ era, which is basically the quantum is available right now. The quantum computing is available, but it is noise prone and error prone. So this error correction is what it's going to, we are going to look at in the next few years. And when that becomes a reality, so we will see like, what is the capability of quantum. So we will have like, some sort of like, something for chemical applications or, something towards chemistry. We will be working on like quantum substantially, like when it improves and when we have something solid, that will go for like several other use cases apart from just being, academic. And the road to post-quantum cryptography standards, NIST has approved like few cryptography standards over the last few months and years. And what we see there is two algorithms, which is Kyber and dilithium, or like approved ones, like which are also widely adopted today. Like only 2% of the organizations or like vendors are capable of handling or accepting the PQC certificates today. And the majority of them are using these two algorithms for their use cases, for their applications and the HSMs and devices. In quantum reality check. So this is basically the roadmap of Google's Willow. So one popular example I have taken. So when Willow becomes available, obviously it's going to have competitors, it's going to have different sources coming up with the quantum computing power. And what does it mean? So what timeline are we looking at the existing encryptions facing a threat. So looking at this, so 2030 or like later, like 2035 or somewhere in between is when this could become a reality of like whether, 4,000 logical qubits, would it be available for, it's not necessarily it's for this purpose and this use case, but basically, is it, true? Yes, it's happening. And today we are at like 100 qubits, and this is what we are looking at scaling towards 4,000 qubits and not error prone and doing these things at scale. And what makes the transition hard? So if we are having like, applications which are critical and crown jewel, the BFSI sectors have already adopted this, and it's been more than a year or like, a couple of years. Some of the industries like, notable names include like JPMC, HSBC, they all have adopted the quantum, and they have, like moved towards in the journey where there's a lot of, exciting content in that space, like on how they executed it. And the common problems that we see in the PQC transition is that one, the latency and size. So it is 3 to 10 times bigger, the key size, what we are comparing between the normal, currently available encryption methods like RSA or ECDSA, between like, dilithium and Kyber. So this possess like the microservices, the mobile applications, the edge devices, the SaaS platforms, everything. So whatever that we are working on today, each and every microservice and API meets a certain SLA, the payload, all of that. So the industry will have to think about the architecture on how we can accommodate this. So this latency is going to possess a serious amount of, significant risk, because it's not, basically the architectures has to be improved is what, we are trying to say. And legacy infra, so we have looked at it. The legacy infra still today like have 10 years as the certificate validity, and the protocol that it operates is like entirely different. And for them to become PQC safe, those algorithms for them to adopt, it is going to take time. And meanwhile, the hybrid certificates is the one which could be the solution for this. Because we also, it's not like, quantum is not there, so we don't have a problem. The data which has been exposed, even if it's encrypted, if you would look into, the bad sources like dark web and other areas, the encrypted data is also being sold. Because by the time the quantum becomes available, the harvest now and decrypt later is what they're trying to do right now. So which is where the shorter validity and the PQC safe hybrid algorithms, I could still use like RSA, but I can have something, compatible along with it to use it. So I could mix up and have it as a hybrid until the end devices and the, like existing ecosystem enables PQC and accept PQC. So this would protect as well. So it's not, a direct jump that we are looking at, we are using like, normal, the existing algorithms, and we are directly going to PQC. It's going to be like the existing algorithms. Then it's going to be the hybrid along with the, PQC compatible, and then the current RSA and similar ones. Then it's going to be entirely PQC. That's something that we look at, post 2030. That's when we are looking at it. And certificate sprawl and shadow PKI. So lack of visibility, basically context to all this. So many organizations don't have this visibility today. So the point is that we need to have a discovery mechanism where we could do a discovery of all the certificates along with the owners and also the end devices like which is using it. And this provides the crypto agility and basically the capability for organizations to understand what is the backlog that they are looking at and how would it help them to move forward. Building a post-quantum PKI strategy. So there are two approaches. One is that, looking at it from a strategy perspective. Two, like how do we technically execute this? Because everything is like good and great when it comes to content, but when it comes to execution, how is it going to help? So where do we start? What do we do first? And how do we execute this? So the different stages that we have seen. So at AppUX, like we help customers to like do this. So there is an open source or freeware that we are, developing right now for like organizations to help. And definitely, if you would put together a lot of open source tools, like we could be able to like achieve this via that as well. So to begin with, discover and inventory all certs, on-prem, cloud, IoT. Now, the certificates of the cloud, think about this, like most of the enterprise organizations use all the three clouds or like, use a mix of like, multi-cloud vendors. And each of them has their own like cert manager, or like, AWS has a cert manager, similarly like Azure and GCP as well. Now, among all this, what are the problems? Like, do I have like one single place where I could, monitor both my on-prem IoT, edge, and also the cloud assets and help organizations to look at their crypto posture? May not be. So the independent vendors may not have the capability to do that, which is where you need to have a holistic approach to like discover the certificates which the organizations are using today, and prioritize risk, the key size, the algorithm. So what we are using today and what are the ones that we should be looking at. We have all the recommendations here, and the NIST standards are available for that. So the tool per se, I want to like quickly jump on the execution part. Like, we are running towards time. So the CryptoBomb scan, the Cyclone DX have published already a CryptoBomb library which you could use, and you can use the cert discovery open source tools. And combining this, you will have both the inventory and the visibility. Once you have into it, like you would be able to do a deep audit, like use cert audit or like PKI security tools to like do the deep audit of those inventory certificates which we have received. And from there, like we can take it to the context and posture. Once you have it, so you will have to implement automation, or like you will have to identify a policy for like your set of applications, cloud, internal, on-prem, everything. So this helps to put together those entire strategy for moving from normal manual rotation and using long-term certificates, and to move away and to adopt the short life cycle certificates, and reducing the manual workload on this and using the quantum safe certificates. So the takeaway: most orgs are not crypto agile today. 2, quantum or not, agility is important and not optional anymore, as the timelines have been published. And CA Browser Forum votes for shorter certificate validity, decreasing it to 47 days. Quantum is coming faster than infra can adapt, as we discussed. And start now, discover, prioritize, and plan hybrid upgrades. These are key takeaways. Any questions?
Please give a round of applause.
Thank you.
Darshan. So if you have any questions, please, I'm not sure which of the QR codes that you put on the slide is the one for the Slido, because there are two.
Yes, the first one is for, the QA is for Slido.
Okay. So if you have, we have one questions. So any recommendations for tools for discovery in inventory?
Yes. For open source tools for just discovery, you could use Project Discovery's TLSX. That's one tool like which is really good, like written in Go, but you need modifications to it because it just looks at 443 and 80. You may have to like, work around a bit to make it useful for you.
Okay. How about client certificates?
So the end devices and client certificates, no, it cannot be discovered by TLSX. You still need a like a way where you could, if you could use automation solutions. There are like more vendors in the market for who also handle the wildcard and client certificates. Companies like obviously the company which I work for, AppUX, Keyfactor, and Venafi, CyberArk. So these are companies like who provide these capabilities today.
Any more questions? Yes, just.
How much does the key size increase the complexity of the program to resolve?
Sorry, how much does the key size?
The key size, you said 248, some people are using, if I was to move to a 4096, how much more complex is the problem to resolve? Is it linear or is it exponential? Or?
It depends also, right? Like what kind of, for example, some applications could have SLAs. Like this is the SLA that we'll have to meet. These are all the million operations that we are doing. This is the, like milliseconds we should be compatible with. But to put it like, is it linear, exponential? It could be exponential because what we are looking at is like from a few bytes to 2.4 KB. That's what, the PKC algorithms, the size of them is. So yes.
I think we don't have time, unfortunately, to tackle the last question on Slido because I think we'll just have like 30 seconds and the question is very long. So please give a round of applause.
Thank you.
Thank you so much.